Hello friends, welcome to the next video tutorial on MATLAB. Today we'll discuss about the different relational and logical operators present in MATLAB and the different types of loops available. The different types of relational operators available in MATLAB are equal to, not equal to, less than equal to, greater than, and greater than equal. So now suppose I have to compare whether A is equal to B or not. So for example, I have A equal to 0 and B equal to sine of pi, which we all know is 0. And now I check whether A is equal to B or not. So it will give an answer as logical 0. It means that A is not equal to B. But we all know that sine of pi is also 0. But why did this happen was because B equal to sine of pi is not equal to 0 in MATLAB. It is equal to this value, which is almost equal to 0 but not exactly 0. So for such comparisons it is better to write a statement like this, that absolute of A minus B is less than equal to epsilon. So now it will give an answer 1. So if we want to compare two numbers whether they are equal or not, it is better to use such statements in place of these statements. Now there are other options, other logical operators also. So the various logical operators available in MATLAB are these: the AND statement, the double AND statement, the OR statement or the pipe sign, the double pipe sign, the XOR and the NOT statement, right? So how do we use these? First of all, let me tell you the difference between a single and the double AND statement. Statement is the single AND statement works both on scalar quantities and the arrays, whereas the double AND statements only work with scalar values, right? The other difference between these two is that suppose there are two logical statements L1 and L2. So in case of this single AND, MATLAB will evaluate L1 and L2 and then check this condition, whereas in this case, if L1 is true, only then it will calculate L2, because if L1 is false, the answer to this logical statement will always be false independent of the value of L2. So if L1 is false, MATLAB will not evaluate L2, whereas in this case both L1 and L2 are evaluated and then this statement is evaluated, right? So this is the basic difference between a single AND and a double AND. And the other difference obviously was that single AND is applicable to both scalars and arrays, whereas this double AND works only with scalar quantities. The same is with this single OR and double OR. Single OR case, both L1 and L2 are evaluated and then the complete statement is evaluated, whereas in this double OR case, L1 is evaluated and if it is true, then L2 is not evaluated, because even if L2 is false, this statement completely is true. And another difference, as I have already told, that single OR can work both with scalar quantities and arrays, whereas the double OR sign does not work with matrices, right? So these are the logical operators as told. So as you know, statements may compose of more than one of these operators in a single statement, so there is a hierarchy of operations, right? So the arithmetic operations are evaluated first in the order previously described, like the BEDMAS. The arithmetic operators follow the BEDMAS method, so all the arithmetic operators are evaluated first, right? Then all the relational operators like this are evaluated working from left to right. Then all the NOT operators are evaluated from, then all the AND statements are evaluated working from left to right, and finally the OR and XOR operators are evaluated working from left to right. So this is the hierarchy followed while evaluating a statement composing of more than one operators. So if this is a small example for XOR, so A is equal to B and exclusive OR basically. So X will be a logical 1. So this is the exclusive OR of A and B, right? Now let's move on to the conditional statements. So the first conditional statement is the if statement, which has a syntax is if, then we give the condition that is to be checked. Then we have the body of the if statement. The if statement has in this case only one condition. We can have a group of conditions by using OR sign or AND sign, right? So more than one conditions can be checked in a single if statement. Let's check this, what this program does. So this program, we have to input two values. We should let us enter A and B, and it will check whether A is less than B. Yes, enter the value of A. The A value of A was 4 and the value of B is 5, so it will print that yes, A is 4 is less than 5, right? In case we had entered the value of A like this, so it will not print, it will not go into this body because this condition is false. So it will not go into this loop and it will come out of, directly come out of it. So in that case nothing is displayed, right? It was a very basic example of a statement. Now another example for if is with else case. So you saw that it did not display anything if A was greater than B. So we can improve the program, the quality of program, by adding an if else statement which says that in case this condition is true, then this statement is executed. Otherwise, or in else case, if this condition is false, in that case the statements under the else heading are executed, right? So let us run this program. So if 4 and 5 as previously done, so it prints that 4 is less than 5, and the other option was if 4 is less than 5. Now this part of the program is executed, right? The first number was 5, the second number was 4, so in this case the else statement was executed. Now again there is one more improved version of else statement with else if statements, right? So we can, if we have more than one conditions to check, we could have also written this program like this, that if A is less than B, else if A is greater than B. We could have written another else if and likewise. So the same can be done with the else if statement also. These are the few examples: if else, and if else if statement. So it is not necessary to write a else condition, it is not necessary to write the else if condition. It depends on your program. So you can simply write an if with an end statement, you can write an if with an else statement, or you can write if with else if statement also, right? So this was about the if statement. Now another conditional statement is the switch case example. So in switch and case, what we do is we have, as the name suggests, different cases of a variable. So let us see this example. So what happens in this example is the value variable will hold a number between 1 and 10, right? So it will check this switch. This is the syntax of the command in which we write switch, the variable which will have more than one states, the various cases or the various possible values of this variable, and the body of the case. So suppose I had entered the value as 5, so it will it will check in which case the value 5 is shown. So value 5 is in this case, so it will display the value is odd, right? Now if I had entered the value as 4, so it will check which case holds the value as 4. So this case has the situation in which value can have a value 4. So in this case it will display the number as even. So we can have multiple cases. We could have also done this as like this, that we could have case 1, right? Case 1 display this, case 3, right, then display this, then case 5, then again display this, because all of these numbers are odd numbers. But the easier way was we added all the conditions together and written a single statement like this, right? So this is more easier. So let us run this program, right? Let us enter 7, the value is odd. So this otherwise case is executed when none of the conditions mentioned in this, none of the cases mentioned are true. In that case, the statements under the otherwise heading are executed, right? So this is all about the switch cases, right? Now another very handy function available in MATLAB is the try catch statement. What it does is that, suppose I have this matrix A and I had only this program, no try written with it. So if I pressed enter and displayed we have to enter the subscript of the element, and by chance I entered the value as 7, but the indexes are only up to 4, so it would have given me an error. This error is because we have exceeded the matrix index dimensions, right? So to have a more interactive program, we can use the try catch statement, right? What happens in this case is I'll write this statement under the try heading. So MATLAB will try out these statements and if there is an error, it will go to the catch statement, with which takes in the argument as m exceptions. So these are me stands for m exceptions. So if there is an error in this try statement, it will go to the catch and do whatever is under this catch heading. So this is some class. This is m exceptions class, which has its members as me.identifier, me.message, me.cause and me.stack. So in me.identifier, it identifies the error. In me.message, it will display the error message. In me.cause, it will display the cause of the error, and in me.stack, it will show the class me that it contains all these subclasses. For example, let me execute this program for you. So in this case, when I run and enter the value as answer as 7, now because the index exceeded the matrix dimension, it will go to catch. It will display me because we have written me here. It will display me m exception, which has these following properties, and because I had written that to print an error message, so this is the message, that index error message as index exceeds the matrix dimensions. I had written here identifier. Let me run this program again. We'll enter 7. Now it will give the identifier. The identifier was the variable that identified the problem in this statement. So the identifier was the bad subscript. So you can also get all these through simply writing me. So me has identifier as this, right? So this is a very handy method of displaying the error inside your statement, right? If we didn't use the try and catch, then the program would have terminated if there was an error in the index matrix. But in this, with the try catch program, we can still run the program without the termination, right? The program is still executed and a message is displayed to the user that the index of the matrix was inputted wrong, right? So you can use try and catch statement in your programs to display such interactive messages. Now we'll see the example of loopings. What different types of loopings are available in MATLAB. So the most common looping statement in MATLAB, while statement. The syntax of this statement is very simple. You write while and some condition with it, or a number of conditions. In this case there is only single condition, but you can write a number of conditions with it. Then some body of this while loop, and finally the end statement. So these statements are executed, right? So these statements will be executed while this condition is true. So let us run this program, and you can see that this body of the while statement was executed until the condition was true. So 9 is less than 10. Yes, 9 is less than 10. Till then this loop was executed. When again x was incremented, so it became 10. Now 10 is not less than 10, so this condition became false, so this body was not executed. This is very elementary way to demonstrate the use of while. You can write any statement inside its body. Another loop option available in MATLAB is the for loop. There are few methods of writing the for loop. The very basic or the first method is this one, in which for the variable I, which will hold the values between 1, this is the starting value, this is the end value, and this is the increment between the values, right? So I will be incremented from 1 to 10 by 1. So the first time the value of I will be 1, then 2, then 3, and so on till 10, and it will print this statement 10 times. So let me execute this example for you. So you can see the value of I for the first time was 1. It was again incremented by 1, now 2, then 3, 4, 5, 6, likewise, right? So these are the ways. This is another way. If you wanted an increment of 2, we could have written 2. If I wanted an increment of 4, likewise, right? This loop can also be written in backwards. The starting value can be 10 and I want to go till 1, so the increment in this case will be negative, or you can say it will be a decrement in value. So in this case you can see now the program ran from 10 to 1. So you can write an incrementing loop or a decrementing loop. Both ways the method is. Another method for loop is this one, in which I will hold these values, right? I in first time the value of I will be 1, second time the value of I will be 3, the third time the value of I will be 5, and likewise. So this is another way of writing the for loop, and you can see the values of I will be 1, 3, 5, 7, and 9. So this is another way of using the for loop. Another way of using the for loop is this one. If you want an increment of 1, like in the first case we were writing like this, in which we were saying that the values are to be incremented from 1 to 10 with an increment of 1. So we could also write it like this also, right? We need not mention the increment in this case. So by default it knows that it has to increment the value of I by 1. Again you can decrement the values. So this is the third method for writing the for statement, in which if we have an increment of 1 we need not mention it, right? The fourth way of writing the for statement is this. In this case the I will hold the values as the first column of this matrix, that is 1 and 4. Then in second case, let me put it like this. So I will hold values as 1 and 4 column matrix, the column matrix of 1 and 4 as the first value, 2 and 5 as the second value, and 3 and 6 as the third value. So I will be a column matrix of elements 1 and 4 for the first time, a column matrix of elements 2 and 5 for the second time, and a column matrix of values 3 and 6 in the third time. These are the 4 different methods for declaring the for statement, right? So now let us move on to the break statement. Now let us see the example for break statement. The break statement is used to terminate a loop based on some condition. As for example, in this program, the values of I from the first statement, the values of I will be from 1 to 15 as 1, 3, 5, 7, 9, 11, 13, and finally 15. So it will display the value of I till the value is not equal to 9. Once this condition is true, it will break the for loop and jump right onto the end statement. So let us execute this program. and run it. So now you can see that till the value of I was not equal to 9, this statement is executed. But as the value of I became 9, this condition became true, and then the break statement was executed. So the for loop was broken and the control came out of this loop and it displayed this statement, right? So this is how we can use the break statement. Now let us see the continue statement. This is different to the break statement because in break statement this loop is broken, whereas in the continue statement the loop is continued by skipping the conditions under this continue statement. So in this case what happens that when the value of I is equal to 3, this statement will not be executed, it will simply continue to the next value of I. So let us check how this program works. So you can see that when the value of I was equal to 1, this condition was not true, so it printed that the value of I is equal to 1. Likewise for 2, but in case of 3, the value of I, when the value of I was equal to 3, it encountered the continue statement, so it continued for the next value of I without further executing the statements in the for loop. So now the value of I would be 4, it would be incremented by 1 from 3, now it will become 4. Again this condition is false, so these statements inside the for loop are executed. When the continue statement was encountered, the statements below this continue statement inside the for loop were not executed and the loop was proceeded. So this is how you can use the continue statement and the break statement. Now let us see the use of logical arrays or vectorization for masking. So in this example, suppose I have an array like this, right, and I wanted to square the values which are less than 5 and square root those numbers which are greater than 5. So the program for that can be like this, right? The program for this can be like this, in which you can see the earlier matrix was this one. Now the values which are less than 5 are squared and the values greater than 5 have been square rooted. But another method of doing this is this one, right? For this, what we can do is, let us execute this on the same matrix. So we can do like this. We can form a logical array B that checks, that holds the information about the elements of A, that whether they are greater than 5 or not, right? So what this will do is, B will now, let me execute this for you. So the first statement is the declaration of matrix A, right? Then we have B. Control V. So now you can see that B is a logical array. B is a 3 by 3 logical array that holds zeros and ones based on this condition, A greater than 5. So if a element is greater than 5, it says 1. If an element is less than 5, it says 0. So because 1 is less than 5, so it holds value 0. So this is how this B matrix is formed. Now I can write this statement, right? What this will do is it will square root all the elements of A where the value of B is true, right? So whichever place B holds 1, those numbers will be square rooted and replaced. So these are the places where B had 1, right? So these numbers are square rooted, and to square the rest of the values we can write this statement, right? So wherever B was false, not of B, says wherever the value of B is 0, raise. So this not B indicates that wherever the value of B is 0, at that position in A, square the number and replace it. So this not of B means to search for places wherever the value of B is 0. So in this row, and these values are 0. So in matrix A, at these positions the value will be squared and replaced. So now instead of writing such a big program, the same can be done by writing in this way, and this is the use of logical arrays, and this should be preferred over this case because the compiler compiles these statements faster compared to this method. So that's it for today. Thank you for watching.